Hi, it's Bruce, and welcome once again to my Colorado Rocky Mountain lab. And today I'm looking at a Keithley 175 auto-ranging multimeter. It's an interesting unit. Earned a certain amount of respect out of me now that I spent some time working on it. It came to me with about half of a LCD display, the other half not displaying digits. And I'll be honest, I don't have a lot of experience at working on the LCDs, so that this was a learning experience and a little bit of a challenge for me. But as you can see, we were really successful, and it's a super bright, high contrast display, and it seems to be working wonderfully. But let's take a look at the unit itself. It's in very good shape. Uh, really, no scratches on it. No cracks or anything, other than there is a slight crack right here. I doubt you can see it, but trust me, they're right coming from the corner of this particular push button. A slight crack that comes up through the plastic here. It's not noticeable. You have to look hard to see it, and it doesn't seem to be hurting anything. I don't know quite how it got like that. Somebody bumped something into it, I would suggest. But any case, that is the only problem on the unit that I could see. Still has the operating instructions on the bottom. The Keithley 175 is an auto-ranging multimeter. You can pop her into auto range and it'll automatically take care of incoming signals for you. It's 10 meg of input impedance on all of the functions, but if you are on the 200 millivolt to 2 volt range, the first two ranges, and you lift all of the function buttons, your input impedance rises to a Megohm. So that's a tremendous gain. It's like 100 times more impedance than a standard 10 Megohm. So you could measure voltage dividers and so on much more accurately. Good to know. It's got 5 digits, so you're a 4.5 digit meter. However, and that's good by itself. But however, your ranges more than make up for a lot of the lack of digits. So we can go down to a 200 millivolt range, and we can actually come up with something very similar to what my Hewlett Packard will read in the low end. So there's a lot of power there. We've got DC volts, AC volts, resistance from 200 ohms up to 20 megohms full scale, I believe. 10 megohms was the calibration point. And we can handle AC voltage, I think up to 750 volts, DC voltage up to 1,000. We can measure current in the 200 microamp range up to 10 amps. And we do that in 6 ranges. We have an automatic zeroing feature. Well, let's say, for instance, and this is kind of a dumb instance, but let's say this was a number that needed to be zeroed for successive measurements that are going to be made. If I hit this REL button up here in the corner, that's now 0. That voltage will be subtracted from anything coming in. I can hit it again and release it, and there we go. We can read dB. So this is dB relative to a 600 ohm impedance, and so like right now we're at 7.78 decibels. If I put this down to I think 0.774 or something like that, it becomes 0 dB, and then you can, if you went to 1/10 of that, it would be 0.0774. You would be reading minus 20 dB. So automatically converts dB, and there's a whole section in the manual that explains some of the benefits and some of the ways to maneuver in the different decibel relative measurements. We have a data logger. We can store up to 100 data points, and we can collect data. I think it's 3 times a second or something like that, up to 1 an hour. So you could go for as long as 100 hours collecting one measurement per hour. And it stores it and then allows you to review it afterwards. Also, it can measure minimum and maximum values. Goodness, what have I missed anything? You have a diode test feature. If you push both these buttons at the same time, it will test with 0.7 of a milliamp, I think it is, the junction of a diode. Very nice unit. And one of the other features, which didn't get a chance to talk about, is that you can calibrate this unit without removing the lid right from the front face here. Long as I don't store anything right now, I'm not going to worry about it. But let's say I want to go into the cal feature. I turn off the unit momentarily, punch in the data logger button, the data button, turn it on. I'm going to see the cal pop up there. I lift my fingers. There's my measurement again. Now I'm going to go, and there's the REL and dB buttons. If I push both of those together and hold them in, I'm again going to get cal up here. And now it's going to wait for me to raise or lower what I'm reading here to the calibration point. So if this was a calibration point 1.9000, and I'm reading 1, I can lower the 1 by hitting the RCL button here to the left. That will take it down. If I hit the store button on the right, it will raise it up. So I can raise my readings to match the incoming voltage, and then when I've done that, I can hit REL and dB together, hold it in, and it will store that as a calibration for this particular range. Like I said, I don't want to do that, so I'm going to just pop myself out. I'm not going to store it, and we'll go back into standard function again. But that is a very nice feature. I did use it to calibrate the unit, and now that I've seen it and used it, I'm impressed. I like it. I'm pretty much used to tweaking pots and so on, and having to remove the cover and having the temperature change after you remove the cover and so on. It's quite a pain. So that's it. It's a nice looking unit. I've got a nice manual that will take you through all of the functions and features. We talk about the input impedance here on the bottom. There is a little compressed operating instruction guide here, and it gives you some of the specs on the unit. So let's go ahead and take a look at the functions here. Okay, so right at the moment we're taking the voltage from this Fluke 343A. It's a nice source of stable voltage. I'm using this HP 34401A, which was calibrated about a year and a half ago, as my standard for the bench, and I'm showing 190 millivolts right now. and we are getting on the 200 millivolt range 190 millivolts, which is exactly what we'd expect to get, want to get in fact. Let's go ahead and go to the 2 volt range, and we're reading 0.190, which is good. And let's take her up to 1.9. All right, there's 1.9 volts, and we're getting 1.900 volts, so that's good. Let's go to the 20 volt range. 1.900. Okay, we got 19.4 zeros, 19 and 3 zeros. Looking good. 200 volt range. Okay, we got 1900. All right, and we're going to go up to 190. We're getting a 190 points, well, within a millivolt anyway, of 190 volts. We're getting 190 volts right on the nose, so that looks great. Going to the 1000 volt range. Okay, we've got 189.9 at roughly, I don't know, 2/10 of a scale. Let's take her up. Now I'm not going to go to 1000 volts because I don't, with these cables and such, I don't trust them, so I'm going to take her up to about 590. Okay. All right, we got 590 on the HP, and we've got 590 on the Keithley. Yeah, we're flashing on and off, maybe on the 10th of a volt, but right there. So voltage-wise, DC, we're right on the money, and it's a nice clear display, crisp. And let's take a look at a AC voltage. Okay, give me a minute. We'll rig her up. Okay, we're on the 200 millivolt scale AC, and we have 190 millivolts coming in according to the HP. 189.99 to 190. We're flashing. Same thing here, 189.99 to 190, so we're right on the money. Let's go to the 2 volt range. Okay, we're showing 189.9 to 190 again, and that's what we'd expect. So now we want to up our voltage to 1.9. 1.9 000. And we're showing on the Keithley 1.9 000, 1.9 000 both, so we're good. Let's go to the 20 volt scale, showing 1.894 on the low end of the 20 volt scale. Let's try 19 volts. Got 19 volts on the Hewlett Packard. We got 19 volts right on the money on the Keithley. Going to the 200 volt scale, we're showing 18.97. We're showing 19 on the HP. So about a 10th scale. We're a little bit low on the low end of the scale. Not abnormal. Let's go to 190 volts and see where we stand. Okay, highest we can go on the AC calibrator is 110 volts here. I'm showing 110.006, 007, somewhere in there, and I'm showing 109.99 volts on the 200 volt scale here. So AC wise, that's good. 110, there we go. Right on the money. So going to the 1000 volt scale, 110.3. That's as high as I can go AC wise. But we're looking good. Very promising. Let's check out the ohms now. Okay, so we set up this resistostat 2, which is a 0.01% device. We've dialed in 100 ohms. We shorted out the leads. We did a 0 on that. We can do that again just to show you. Go ahead and short the leads. I'm getting 0.66 if I hit 0. Okay, it's going to remember that. And doing this one-handed here. Okay, so for 100 ohms of input, we're getting 99.98 ohms. Let's go ahead and go to the 2K scale. Again, we're getting a 0.1K, which is 100 ohms. And we want to go to 1K. Okay, and we got 1K right on the nose. Go to the 20K scale. We want to get 10K in this case. Okay, here's 10K. 10K right on the nose. Going to the 200K. Okay, we're showing 9.99K, 10K. Okay, we want to get 100 dialed in here. Okay, we dialed in the 100K and we are getting a 100.00 to 01K. So that's good. Let's go to the Megohm range. We're showing 0.1 Megohm. It's 100K. That's good. Let's go to 1 meg. There's 1 meg. And let's go to this is 10 meg, and we're showing 10.000 meg right on the nose. So ohms is looking good. So the only thing left is the amps. Let's take a look at it. Okay, so we've set ourselves up in current mode, DC current. We're reading from this Keithley 225. We're at its maximum output right now, about 100 milliamps. We are connected in series with the HP to read current. And right now we are getting 100 milliamps to within 600 millionths of an amp, and what we're showing is 100 milliamps on the 2000 milliamp scale. Okay, let's go to the 200 milliamp scale. We're showing 100.00. Very good. Let's go down a step. Okay, we're now going to be reading 10 milliamps. Adjusting for 10. Okay, 10 and 4 zeros, that's close enough. And on the 20 milliamp scale, we're showing all 9s are a 10, which is good. On the 200 milliamp scale, 10, so that's good. Let's go ahead and drop ourselves down again. This time we're going 1 milliamp. We want to adjust for 1, almost. Let her settle just a minute here. Alright, there's 1 milliamp within 4 decimal places. We're showing 1 milliamp on the 20 milliamp scale, and we go to the 2 milliamp scale and we're showing all 9s to 1 again. We're mimicking the HP. So beautiful. Let's go ahead and reduce her down another notch, and at this point we should be reading 100 microamps. There is 100 microamps within 1 decimal place anyway. And I see that we are going from 0.039s to 0.1 milliamp. So that's looking pretty good. Let's go to the 200 milliamp scale. That was on the 2 milliamp scale. And 99.97 or 8. Okay, I'm connected up to this constant current source at the moment. Okay, we got about 1,000.5 or 6, and we're getting 1,000.3 or 4. Right now, 4s are on both. It's kind of hard to jerk you around. Sorry about that. So that's 1.005 amp on both. And that's on the 2 amp scale. And if I go to the 10 amp scale, should be basically an amp. So thank you for listening, and happy bidding. I think you're going to like this this meter. I do. Bye.